So number 3 reads, you are trying to plan for retirement in 10 years. Currently you have $100,000 in a savings account and $300,000 in stocks. In addition, you plan on adding to your savings by depositing $10,000 per year in your savings account, not the stocks, at the end of each of the next 5 years, and then $20,000 per year at the end of each of the following 5 years, the last 5 years, until retirement, retiring in 10 years. Okay, part A, assuming your savings account returns 7% compounded annually and your investment in stocks will return 12% annually, how much will you have at the end of 10 years, ignoring taxes? So first let's deal with the savings. We have $100,000 in savings. We're going to divide this up into parts. So the first part is, and again, this is number 53. So this is $100,000 in savings. So that is going to earn interest for 10 years. So it's future value. We're trying to find future value, how much we'll have at retirement, which is 10 years from now. So it's going to earn interest for 10 years at an annual rate of, looks like 7%. And we're not considering the other payments, so PMT is 0. And of course, that's the present value is 100,000. So putting those in your calculator and solving for future value, you'll get how much? 100. This is in year 10. 196,715. Okay. Second part of the question is we'll do with the stock. We have 300,000 in stock. What is that going to be worth in 10 years, assuming that it's getting 12%? So n is still going to be 10, I is 12, change I to 12, set present value equal to 300,000 negative. And there's no annuity portion for this either. And solve for future value as we did before, and we'll get your stock should be worth 931,754. Now we dealt with your savings and your stock. Thirdly, what else do we have? Let's see. It says we're going to deposit $10,000 per year for the next 5. Well, let's see. What's it say exactly? In addition, you plan on adding to your savings by depositing $10,000 per year in your account at the end of each of the next 5 years, and then $20,000 per year during years 6 through 10, at the end of years 6 through 10. Just to save time, I'm going to look at that as a 10-year $10,000, a 10-year $10,000 annuity that starts now. So with the first payment 1 year from now, and the last payment 10 years from now, plus a 5-year $10,000 annuity that doesn't start until 5 years from now. You follow me? Maybe a timeline would be helpful. You have $10,000 per year for the first 5 years, and then $20,000 in the following 5 years. So I'm looking at it as a 10-year ordinary annuity that is $10,000 per year for all 10 years, plus another $10,000 annuity years 6 through 10. You see how that is consistent with what they're saying in the problem? So that would be $10,000 for the first 5 years and then $20,000 in years 6 through 10. But I'm just looking at a 10-year $10,000 annuity plus a 5-year $10,000 annuity that doesn't start until 5 years from now. That makes it a little bit easier. So 3 is going to be actually going to be 2 parts. First, the 10-year annuity. So actually, there'll be a 4th part. A 10-year annuity of $10,000 per year. So setting n equal to, this is number 3 still, set n equal to the number of annuity payments, which is 10, the interest rate is it's in our savings account, right? So 7. Annuity payments is 10,000, and there's no present value. And solve for future value. You want to know what it's worth at the end of the 10th year here, so that would be a future value, and you get 138,164. And then finally, we still haven't taken into account this part yet. The 10,000 per year and the 10,000 per year extra in years 6 through 10. That's a 5-year annuity of 10,000 per year, earning 7% per year. Solve for future value. It's going to be a future value in what year? At the end of this annuity's lifetime, which is actually at the end of year 10, which is what we want. Convenient, huh? See, if we were trying to find the present value of this annuity, we would have to take it back 5 years. But we're not looking for present value. We're looking for future value at the end of the last year of this annuity. So that's already a year 10 value. We don't need to convert it like we did in the last problem. So solve for the FE sub 10 of year 10 future value, 57,507 is what I get. Okay. Now, and add all these together, FV1 plus FV2 plus FV3 and so on, gives us a total of 1,324,140. That's how much we have at the end of 10 years. And that's part A. Now we have part B. B says, if you expect to live for 20 years after you retire, and at retirement you deposit all of your savings in a bank account paying 10%, how much can you withdraw each of those 20 years after retirement? Starting with 1 year after you retire. So you end up with 0 balance after death. So for this, we have our present value. At the end of the 10th year, we have our 1 million. I just got rid of it, but it was 1 million. 324. 140. I'm just going to make it negative because it's like we're depositing that into this new account that's paying 10% interest. We're going to make withdrawals for 20 years, it says, n equals 20. 20 total withdrawals, and that's a 10-year annuity. Our withdrawals are a 10-year ordinary annuity that starts, well, 11 years from now, 1 year after you retire. So times 0 is going to be our retirement point for part B. There's no, we want the balance to be 0 when we're done. Put those in your calculator and solve for how much we can withdraw per year payment, PMT. You'll get 155,533.